Hello everyone, and welcome back. Did you know that Earth's invisible shield, the magnetic field, has weakened by about 30% in the last 3,000 years, and it's still dropping? This isn't just a minor change, it might be the beginning of something much bigger. Stick around, because I'm about to reveal how this incredible force protects us daily and what could happen if it starts to falter. Our planet's magnetic field acts as our first line of defense, an invisible barrier extending far into space. Without it, Earth would resemble Mars, a barren world stripped of its atmosphere by the relentless solar wind. But what exactly is this shield, and how does it function? Think of Earth as a colossal bar magnet. However, instead of solid metal, its core is a vast ocean of liquid iron, swirling deep beneath our feet. This molten sea, located about 1,800 miles below the surface, generates electrical currents hundreds of miles wide, flowing at thousands of miles per hour as Earth rotates. Scientists call this the geodynamo, nature's own power plant. This spinning metal creates a magnetic bubble around our planet, known as the magnetosphere. It's not a perfect sphere, though it's more like a windsock in space. The solar wind, a stream of charged particles from the sun, compresses it on the side facing the sun and stretches it into a long tail on the opposite side. Here's the truly fascinating part. This magnetic field creates two enormous donut-shaped zones called the Van Allen belts. These belts trap harmful radiation from space, acting like Earth's very own particle accelerators, catching cosmic rays and solar particles before they can reach us. However, this shield isn't as stable as we once believed. In fact, something quite unusual is happening to our magnetic defenses right now, and it's progressing faster than anticipated. Remember how I mentioned our magnetic shield is weakening? Scientists have identified a massive weak spot over the South Atlantic Ocean, stretching from South America to Africa. They've named it the South Atlantic Anomaly, and it's like a dent in our magnetic armor, where the field is significantly weaker than elsewhere. This weak spot isn't just a scientific curiosity, it's already causing tangible issues. Satellites passing through this region frequently experience electronic glitches and failures. It's as if they're traversing a cosmic vulnerability where our shield can't offer its usual protection. But that's not all. Earth's magnetic poles are on the move. The magnetic North Pole is racing towards Siberia at an astonishing 34 miles per year. That's about 3 times faster than it was moving in the 1990s. Imagine if your compass became less reliable with each passing year. Scientists have found evidence of this pattern in ancient rocks, revealing that Earth's magnetic field has completely flipped hundreds of times throughout our planet's history, with north becoming south and south becoming north. The last major reversal occurred approximately 700,000 years ago. But how does a magnetic flip actually happen? Recall that ocean of liquid iron. Changes in its flow can weaken some parts of the field while strengthening others. During a reversal, the field doesn't simply switch off and on like a light. It's more akin to a dimmer switch that gradually fades down and then rebuilds itself in the opposite direction. This process can take anywhere from a few hundred to a few thousand years to complete. During this transition, we wouldn't be left entirely defenseless. The field becomes more complex, with multiple magnetic poles appearing in unexpected locations. Think of it like a choir transitioning between songs. There's a period where both melodies overlap. What's crucial to understand is that we're not necessarily facing an imminent flip. Scientists have identified shorter events called excursions, where the field weakens significantly but then recovers without fully reversing. These happen about 10 times more frequently than full reversals, and we might be entering one of these periods now. So, what does all of this mean for life on Earth? First, the good news: we're not heading for a doomsday scenario. Life on Earth has successfully navigated hundreds of these reversals before, and there's no evidence that past reversals caused any mass extinctions. The most immediate effects are already observable in our technology. Satellites passing through the South Atlantic Anomaly require extra shielding, and some even shut down their sensitive electronics when traversing this region. As the field continues to weaken, these effects could become more widespread. What about radiation reaching Earth's surface? Here's something most people don't realize. Our atmosphere is actually our primary shield against radiation, and it's as effective as a 13-foot thick concrete wall. Even if the magnetic field weakens significantly, our atmosphere will still protect us from most harmful radiation. However, some animals might face challenges. Species that rely on magnetic fields for navigation, such as sea turtles, whales, and certain birds, would need to adapt. Given that these changes occur over many generations, they would likely have ample time to evolve new navigation strategies. Scientists estimate that at the current rate of decay, it might take several centuries or even a millennium before we reach a critical point. This gives us valuable time to prepare our technology and infrastructure. Space agencies are already developing enhanced radiation shielding for satellites and spacecraft. Power grid operators are installing equipment to protect against geomagnetic storms, which could become more common as the field weakens. We are living in a unique era where we can actually study this process as it unfolds. Satellites like the European Space Agency's Swarm mission are constantly monitoring our magnetic field, allowing us to learn more about these changes than ever before. So, while Earth's magnetic field is indeed changing, it's not a cause for panic. This is a slow, natural process that our planet has experienced many times before. What makes this time different is that we are here to witness and understand it. If you found this exploration into Earth's magnetic future intriguing, please hit subscribe for more videos about our ever-changing planet. And tell me in the comments, what surprised you most about Earth's magnetic field, the fact that it's weakening, or that our atmosphere is actually our main shield against radiation? Don't forget to check out the video on the right. Thanks for being part of our knowledge community.